All right, so as you came in today, you should have picked up the 4.3 Special Right Triangles worksheet. That worksheet goes along with the video that you need to watch over this weekend. Okay? So that worksheet can be put away. Nope, all the way over. That worksheet can be put away right now because you need to watch the video to go along with it. You can take notes off of the video right on that worksheet. Okay? And then, so that one is sometime before Tuesday's class. Okay? So we've got that going on. Today, some of you have your unit circles, and I can see them as I'm looking around the room. They're on yellow papers from Algebra 2. We're going to redevelop that again today. So if you want to keep that away, don't get it out. We're going to redevelop it today because we're mean in this class. We don't give you that, and you don't get to use that on any test. Okay? You will have to, one, memorize the unit circle because we use it so often, it's just quicker to have it memorized. And two, you get to redevelop it every time. Teach you the tricks on what to do on developing the unit circle. Okay? So here we go, developing the unit circle on Wednesday. I had to think there for a minute what day it actually was. On Wednesday, we said that the unit circle was x squared plus y squared equals 1. It's a circle centered at the origin with a radius of 1. And that 1 can be whatever 1 you want it to be. Whatever unit you want that 1 unit to be, that's your unit. If you're thinking feet, think feet. If you're thinking inches, you're thinking really small. If you're thinking miles, you're a big dreamer. Okay? And so wherever you want to put it at, that's where you put it at. Okay? All right? So with that being said, it's fairly easy to find certain points on the unit circle. And we call those points the sweet 16. Okay? Because those 16 points are really easy to find on the unit circle. Okay? 4 of them super duper easy. Okay? So let's find those 4 super duper easy ones right now. So we always need a place to start. So the start of the unit circle is actually right out here, straight out to the right. Almost said straight out to the left, but it's straight out to the right. And that is the point 1, 0. 1, 0 makes that, or the equation of the unit circle, x squared plus y squared equals 1, it makes it be true. So it's on the circle. All right? In terms of angles, this is at 0 degrees or 0 radians. Is that point straight out? Okay? Now, if I go all the way around my unit circle, how many degrees have I gone? 360. How many radians have I gone? 2 pi. So this point is also 360 degrees or 2 pi radians. Because we go all the way around one circle. Side note, if you haven't drawn yourself a circle of some size on your notes, you should probably draw a circle of some size on your notes that you can draw this in. Forgot to tell you that. That's my bad. My bad. So you're using that. Okay? Halfway around the circle. Right? So if I start there, halfway around the circle would be right over here, and that would be at the point -1, 0. Well, how many degrees is halfway around the circle? Somebody mumbled it, I heard. 180. Halfway around the circle is how many radians? 5 radians. Okay? So this point would have an angle of 180 degrees, or pi radians. When we plug those angles into our trig function, into our 6 trig function, that would be the angle that we're talking about. Then we got 2 other easy ones. We could go straight up. Paula Abdul used to sing the song, "Straight Up, Now Tell Me That You Really, Really Want to Love Me Forever. Whoa, whoa, whoa." Okay. That would be the point 0, comma, +1. Half of halfway around the circle is how many degrees / radians? 90 degrees. Pi over 2 radians. Bottom half of the circle. Come on now. Bottom half of the circle would be at 0, comma, -1. (270 degrees would be halfway between 180 and 360. 3 pi over 2 would be halfway between 1 and 2 pi. Good so far. Okay. So those are the 4 easy ones to get to. Now there's 12 more. There's 3 in each quadrant. Okay? I'm going to focus in on quadrant number 1. And the reason I'm going to focus in on quadrant number 1 is because I call it the positive quadrant. And I'm all about positivity. Okay? And so both the x-coordinate and the y-coordinate in quadrant number 1 are positive. I'm not a quadrant 3 type of person today. That's the negative quadrant. Everything else is negative. We're sticking in quadrant 1. We got sunny. We look outside and I don't see clouds. I see the sun. Sunny. Mm-hmm. Really sunny outside. Okay? Okay? So how we go about finding those extra 12 points is later on we're going to count radians, okay? But finding the actual, I shouldn't say, we'll count radians first, okay? So if I'm counting radians, so we went half of half, okay? So halfway between 0 and pi over 2, half of a half is a quarter, right? So this would be 45 degrees, or pi over 4 radians. 90 divided by 2 gives me 45. Pi over 2 divided by 2 gives me half of half. Okay. Now, how I go about actually finding the coordinates of that point, I'm going to use a special right triangle. And that special right triangle is the 45-45 right triangle. It's special because both of the base angles are congruent. They're equal. Both are 45. Because that's true, back when you were a tree in geometry, you should have learned that the legs are also congruent. Because when the base angles are congruent in a triangle, it's an isosceles triangle. Now, how they went about figuring out how it was root 2 over 2, and just so you are aware, we love root 2 over 2 more than we love 0.071. We love exact answers, don't like the rounded answers. Yeah. How they said that was, oh, well, those two legs, they're equal. Let's call them x. The hypotenuse is 1 because the radius of the unit circle is 1 unit. So let's call it 1. And then our old pal Pythagoras came up with a theorem that says that the square, or the sum of the squares of the two legs of a right triangle is equal to the square of the hypotenuse. And so then we said, well, if I got an x squared and you give me another x squared, that's 2x squared. 1 squared is 1. Can divide both sides by 2. I can take the square root of both sides. When I take the square root of a fraction, well, that's really taking the square root of the top and the square root of the bottom. Well, that's just 1 over the square root of 2 then. Still not the square root of 2. So then they said, oh, well, let's rationalize that denominator. Let's multiply it by the square root of 2 over the square root of 2. And we can do that mathematically speaking because we're multiplying by 1. So then that became the square root of 2 over the square root of 4, which is the square root of 2 over 2. So with that being said, then this now, since this is 45 degrees, half of my upper quadrant quarter, then this triangle right there has a hypotenuse of 1. It's got a 45-degree angle for both of its angles. It's a right triangle. So then both of those sides would be square root 2 over 2. So we got that. And then the mathematicians, in their wonderfulness of mathitude, sitting around the mathatoriums back in the day, they said, well, there's another special right triangle out there, and that one is called the 30-60-90 triangle. And they discovered that there's always this ratio going on in a 30-60-90 triangle, as long as you know which side is which. So then they basically said, gosh, we got to teach these kids in geometry that the longest side of a triangle is opposite the biggest angle. And then the shortest side of a triangle is opposite the smallest angle. And the middle length triangle is opposite the middle length angle. And so your geometry teacher should have taught you that. Now, you might have forgotten that. So, just like Jay-Z, allow me to reintroduce you to that. Okay? So, if I am in a 30, 60, 90 triangle, then the shortest side would be across, I shouldn't say side. I immediately regret saying side. I'm going to say leg. And then the one across from the 60 degree would be what's called the long leg. And then the other one is the hypotenuse, which is really the longest side. Okay. So how does that relate then to the unit circle? Well, if we take our triangle and now we say that our hypotenuse is 1, so we would say that 2a right here is 1 from right there, then a has got to be 1/2. So a is 1/2. Shabam, there is my short leg, and it's 1/2. Then to find my long leg, I got to multiply that short leg by the square root of 3. So that's where the square root of 3 over 2 comes. How does that translate back to our unit circle? Well, let's go back 2 slides. So now we have to find our 60 degree angle, which makes this be the long leg, which makes this be the short leg, which makes this be 1/2, and the long leg be the square root of 3 over 2. So my x value here would be 1/2. My y value would be the square root of 3 over 2. And that would be for a 60 degree or a pi over 3 radian The nice thing about a 30, 60, 90 triangle is that if I turn it on its side, now that 60 degree angle is up here, and that 30 degree angle is down there. And so then this becomes my long leg, which is the square root of 3 over 2. This is my shorty, and that's 1/2. So this would be, that point right there would be the square root of 3 over 2, comma 1/2. For a 30 degree or pi over 6. a second here to erase. So that is quadrant number 1. The reason I focus so much on quadrant number 1 is because if you've seen the pattern, which you all went through algebra 2, you saw the pattern. Okay? But if you also just notice, we can take that, all those values in quadrant number 1, and I can flip them over into quadrant number 2. So this point right here would have the coordinates of negative square root 3 over 2, comma, positive 1/2. Because all of the points in quadrant number 1 are positive, positive, all the points in quadrant number 2 are positive, negative. Excuse me, negative, positive. Which then means that this point right here would be negative root 2 over 2, comma, positive root 2 over 2. This point up here would be negative 1/2, comma, root 3 over 2. This gap down here and this gap right there are both 30-degree gaps, because that's what they were over on that side. So this would be 120 degrees. This would be 150 degrees. The green is going to be halfway between. Halfway between is 135 degrees. We just got to convert those now into radians. Okay? So here I went 1 pi over 3. So this would be 2 pi's over 3. .30 degrees is pi over 6. Pi is 6 pi over 6. So this would be 5 pi over 6. If I take away 1 pi over 6 from 6 pi over 6, I've got 1 pi over 6. Let's see. 1 pi over 4, 2 pi's over 4, 3 pi's over 4. Now I can take that whole top and I can reflect it down to the bottom. Knowing that in quadrant number 3, everything is negative, and in quadrant number 4, the y-coordinates are negative. So then this would be, we'll go with these two first. So this would be the square root of 3 over 2, comma, negative 1/2. Over here, it would be negative square root of 3 over 2, comma, negative 1/2. This would be 330 degrees, or 11 pi over 6. This would be 210 degrees, or 7 pi over 6. Those two would be flip-flop the x and the y's, invert the x's and the y's. This one would be 240 degrees, or 4 pi over 3. This one would be 300 degrees, or 5 pi. And then the last two, we've got the quarters, negative root 2 over 2, negative root 2 over 2, root 2 over 2, negative root 2 over 2. And those then would be at, so this would be 225. Or 5 pi over 4, and this would be 350. Or 7. Whew! And those are our sweet 16. Now, on Tuesday, we also learned those 6 relationships that we have on the front board. That the cosine of any angle is the x value of that angle on the unit circle, or the x coordinate of the point that corresponds with that central angle on the unit circle. Okay? The sine would be the y coordinate of that. So when I have a problem that looks like this, the sine of pi over 6. You're going to have one of your 6 trig functions, and then you're going to have an angle either in degrees or in radians. Okay? So what this is saying, the sine of pi over 6, this is saying you want the value of the y coordinate at a central angle of pi over 6. So we go to our pi over 6, which just happens to be right there. There's pi over 6. And I look at the y coordinate of the point that's on the unit circle, and that's 1/2. So So the sine of pi over 6 has a value of 1/2. The sine at 11 pi over 6 is asking, what's the y coordinate at 11 pi over 6? Anybody? Negative 1/2. Cosine at pi over 4. Now I'm looking for the value of the x coordinate, because cosine is x. What is the cosine at pi over 4? Square root of 2 over 2. and the cosine at 5 pi over 4. X coordinate of the point at 5 pi over 4. Negative square root 2 over 2. Negative root 2 over 2. Again, we will not, going forward, be giving you a unit circle sheet to use on any test or quiz or formative. You will have to supply your own from memory. Okay? And during said tests and quizzes, we'll drop this middle shade and we'll cover up all the unit circles. We've done it many, many times. Okay? That's all I got for you today. Thanks for playing along.